Hello all. In this session, we're going to understand the regression model for classification. But before that, let us recall what is this linear regression. If you do recall, a linear regression is a simple and widely used statistical method for modeling the relationship in between dependent variable. Let us say y is equal to mx plus c. Let us see, just a minute. Y is equal to m x plus c or whatever wx into b, like the and one or more independent variables. This is a dependent variable, x is an independent variable, where c is the intercept here, right? Now it's a simple form. The model is represented as y is equal to mx plus c, where y is the predicted value, okay, and x is the input value, where x is the input value, and w is the m is the slope, and c is the intercept, the bias. We already knew this. But the problem, see here, y, if the y is greater than or equal to 0.5, is classified as one class. If y is less than 0.5, it just classify the other class. If it is binary classification, it works really fine. We already knew this. Okay. And there also is like multiple linear regression is w1, x1, w2, x2, so on, wn, xn into b, where this is a multiple linear regression. But the thing is, the problem with the linear regression is it assumes that the output can take any value, which is not ideal for the probabilities which range between 0 and 1. Okay, so the linear regression is not robust to the outliers of the data. If there are outliers, so the linear regression doesn't work. As simple as this, because linear regression doesn't handle the outliers well. So it does not model the boundaries in between the classes effectively. If there are multiple classes, it will not be able to draw the boundaries effectively, so that the multi-class classification would always be a biggest problem. To address these issues, we just have, introduced, we are introduced with something called a logistic regression. What is logistic regression? Logistic regression, as we discussed at some point in our, the EL program, logistic regression is specifically designed for the classification task. Okay, it is exclusively designed for the classification task. It overcomes the shortcomings of the linear regression by using a sigmoid function, okay, to map the predicted value into a probability that is in between 0 and 1. How logistic regression works? We know that z is a dependent variable, where w1, x1, this is our logistic regression started by calculating the linear combination of the input features. This is the linear combination of the input features. Sigmoid function here, the sigmoid function sigma of z or x, whatever, is equal to 1 by 1 plus e power minus z, okay, where z is the input value. Okay, output, here e is the Euler's number. He is a Euler's number. Okay, 2 point something. It's just a Euler's number. Output sigma of z is always in between 0 and 1. The value represents the probability of the positive value. It just, I mean, the probability of having a positive value is being classified into 1 is p of y is equal to 1 is, it should be greater than 0.5 earlier. The value represented by the probability of the positive class, this value. Okay, here there are two classes, 0 and 1. Okay, let us say it's a dog. Okay, we are actually just, it's not writing good, but anyhow, this is 1 is a dog and 0 is a not dog. Now the probability of having the given image classified into a dog should be anywhere near to 1. If it is not equal to 1 or anywhere near to 1, the image will not be classified as a dog. It will be classified into the others. Okay, this is a wonderful technique to the regression, the classification problems. Here the decision boundaries, as we discussed, sigma of z, if it is greater than 0.5, will be equal to 1, less than 0.5. It can be predicted into the other class. 1 will be the taken class, 0 will be the other class, such as dog or a not dog. Here, in the loss function, what we're going to use, we are going to use the cross entropy loss. Here, we are not going to use the mean square error. Logistic regression always uses the cross entropy loss. The loss is equal to minus y into log y cap minus 1 minus y into log 1 minus y cap. Here, where is y is the true label, 0 or 1. Y cap is the predicted probability. Here, this is a predicted probability. This is a sigma of z. It's a predicted probability. The loss function penalizes the predictions that are far from the true class probabilities. If it is by using the loss function, it's going to penalize the probabilities that actually are far from the true probability. For an example, there is a dog, there's an image which is not being classified into the dog. So it is the value is somewhere nearer to 0. So it will be able to penalize, and it will be able to identify correctly that it is not going to belong to the dog image. Okay. So then we're going to provide the training function. We just are going to calculate training function. The gradients will get calculated. The derivatives of the, what do you call the weights and updations. First, initially, we're going to, in the back propagation, we're going to calculate the gradients. Then we are going to update the weights where n is the learning rate. Generally, the learning rate will be 0.01. So here, the advantage of the logistic regression will be the probabilistic output. Unlike the linear regression, logistic regression outputs probabilities. Okay, it's going to probabilize the output. The probability of given image to be classified into either dog or not dog. It is going to give you the probabilities. Okay, simple and efficient. Logistic regression is fairly simple. The sigmoid function makes it robust and fairly simple. Well-defined decision boundary, and we will be able to mark the boundary appropriately in between the classes of 0 and 1. And it will also be very used for the multi-class classification. The regression can be extended to multi-class problems using one versus rest, or the softmax regression. We can also use softmax regression for the multi-class classification. Okay, but there are also a few limitations to the logistic regression. Linear decision boundary, such as linear decision. What is the linear decision boundary? Logistic regression assumes that the relationship between the input features and the dog odds are linear. Log odds are pretty linear. It struggles with the complex and non-linear patterns. If the pattern is linear, it works fine. If the pattern is not linear, it's not going to work really well. And obviously, it's sensitive to the outliers. Outliers can, influence, because there is, similar to the linear regression, logistic regression also is pretty sensitive to the outliers because there is no effective way of handling these outliers. Okay, and feature scaling, the logistic regression often requires features should be scaled. We should be able to standardize. There has to be a lot of standardization to be applied to the input data. Okay, so that's all about logistic regression. Thank you so much.